Okay, finally back on Chapter 9. Today's Sunday, and I apologize for getting to this so late in the week. I got requests on this problem probably about 3 days ago or so. It's just been really busy, and as I'm sure it is for most of you out there. So if you find you need a day or two extra for you to complete this problem, and maybe the other one or two for the chapter, let me know, and I can extend your due date. But anyway, Chapter 9 is on standard costing and variance analysis, and so this is good stuff if you're working in more of a manufacturing environment, which, you know, admittedly we don't have a whole lot of in Hawaii. Certainly not too much on the Big Island. Maybe a little bit on Oahu if you happen to end up there for work. But you know, if you end up anywhere else, different places on the mainland, you could easily find yourself in a situation where this sort of material would apply to what you do on the job. But at any rate, you know, like all accounting material, just to be able to go through this in an academic setting, in a classroom, in a course like what we're doing, would be very beneficial to you down the road in pretty much any job setting where you're having to problem solve. A big part of accounting is problem solving, and that sort of skill is something that you can develop, refine and develop over time moving forward. And you'll find in life that problem solving skills can be invaluable to you in not only in work situations but in many other situations as well. But anyway, here we go. Pa9-1, calculating direct material, direct labor, and variable overhead variances. Now, I know I got a question about this problem a few days ago, and I wasn't able to get to doing a video like I want to do now, but I directed the student to the textbook pages 380 through 388, and that's the section in Chapter 9 on variable cost variances. And to be able to work through a problem like this, this material is not like much of accounting. This is not stuff that you would necessarily memorize. I mean, if you're doing this kind of work day in, day out, year after year, then over time, you know, it's just going to be something that you remember without even thinking about it, really. But for the average person, you're not going to be memorizing this stuff. But what's more important is that you are able to find a reference and use it. So in our case, the reference would be the textbook, and the textbook for this material, it provides excellent diagrammatic types of examples. Exhibits 9.5, 9.6, 9.7, and 9.8. basically kind of walk you through it and give you the simple formulas you need to be able to calculate these variances. So with that said, let's take a look at problem Pa9-1. And as I have in the past, I'll try to record the calculations on an Excel spreadsheet. So, okay, what do we have here? Barley Hop Inc. manufactures custom ordered commemorative beer steins. Oh, pretty cool. Custom ordered commemorative beer steins. Its standard cost information follows. So, for their beer stein manufacturing process, their standard cost information includes direct materials, which is clay. 1.6 pounds is their standard quantity. Their standard price or rate is $1.70 per pound, and their standard unit cost is $2.72. So if you were to multiply 1.6 pounds times $1.70 a pound, that's how you would get your $2.72. Maybe we ought to show some of that information here. Let's say Stein Manufacturing, and so we have direct materials, which is our clay, and our standard quantity why don't we move this down? There we go. And our standard price, or our rate, and our standard unit cost. So that's 1.6 pounds. This is $1.70 per pound and $2.72, and these two amounts are dollars, formatted as dollars. Whereas this amount should be formatted as a number. Okay. Maybe we ought to show that Okay. Then we have our direct labor. Well, that isn't going to work because pounds will apply to material, but not to, yeah, let's just use standard quantity. Our standard hours time to make these steins is 1.6 hours. Standard rate would be $14 an hour. And again, if we multiplied 1.6 times 14, that would give us our standard unit cost of $22.40. And actually what we ought to do here, instead of using a number, is just do a calculation. That's probably better. 272, 22.40. Okay, so now we got a formula there. That's better. Variable manufacturing overhead. Variable manufacturing overhead based on direct labor hours. We have 1.6 hours at $1.30 per hour, and so if we multiply those two out, that would give us our 208. And then finally our fixed manufacturing overhead, and that formula is given there in the problem. 352,000 divided by 160,000 units. So this is $352,000 of fixed overhead, and our baseline production quantity in units, so I'll put a U in there, is 160,000. And so if we let's make this a formula. 352 divided by 160. I guess we need to show that's a formula there. $2.20. So our standard unit costs for steins would be the total of that column there, $29.40. Okay. And then actual results. So let's call this standard cost information, and then actual results. Units produced and sold. $165,000. Number of pounds of clay used, 298, 200. Cost of clay used, 536,760, and that should be formatted as a currency. Okay, these two will be formatted as numbers. Okay. Number of labor hours worked. $210,000. Direct labor cost. Hours times rate was 3,780,000, and again this should be formatted as currency. Okay. Variable overhead cost and fixed overhead cost. 320 and 365. Okay, so that gives us some actual data. Okay, so based on standards and actual, what we need to calculate are the cost variances. How did actual differ from or vary based on what they expected to happen, which would be their standards. Okay, so we take this one at a time. In requirement 1, we're being asked to calculate direct material price, quantity, and total spending variances. In requirement 2, they're asking us to calculate direct labor rate, efficiency, and total spending variances. And then in requirement 3, they're asking us to calculate the variable overhead rate, efficiency, and total spending variances. And so if we refer to our text on those pages and looking at those exhibits that I mentioned in the beginning of this video, we would focus on Exhibit 9.6 for our direct material price and quantity variance, and Exhibit 9.7 for our direct labor rate and efficiency variance. And of course on both of those, the combination of the price and quantity variance for direct materials gives us the spending variance, and for direct labor, the combination of the rate and efficiency variance gives us our spending variance. And then for the last one, variable overhead rate efficiency and spending variances, we refer to Exhibit 9.8. And if we take a look at that exhibit, we see that the combination of the overhead rate variance and the overhead efficiency variance gives us the overhead spending variance. So all 9 of these variances we can calculate by referring to these exhibits in this section in the text. Okay, so let's see if we can do these based on the material given in the problem and by referring to each exhibit in the text one at a time, starting with Exhibit 9.6 on page 383. So let's take this one at a time. We start with requirement 1 and the first item, direct materials price variance. So direct material price variance, and so this would basically compare our standard price versus our actual price for our material. Our standard price was $1.70, and so we need to compare that with our actual price. And so we go to Exhibit 9.6, and that basically gives us the formula for each one of these items. So to get our direct materials price variance, we take actual quantity times actual price. Actual quantity times actual price. So let's put that in there. Actual quantity times actual price. And we compare it to actual quantity times standard price. Actual quantity times standard price. And the difference between these two calculations give us our price variance. So what was the actual quantity? Number of pounds of clay used, 298.2. That's our actual quantity. 298.2. Those are pounds, so we want to format that as a number. And our actual quantity is the same for both calculations. And this is actual and price actual standard. Okay, so our actual price, let's get our standard price. Our standard price is $1.70. And this is a dollar amount, $1.70. Now to get our actual price, this may be a calculation if it's not given up here in the problem. So we had number of pounds of clay used and cost of clay used. So this is going to require a calculation. So let's show a couple of asterisks like that, and then we can show that that calculation is total cost $536,760 divide by cost number of pounds of clay used 298.2. Okay, so this calculation is going to give us our actual price, $536,760 divide by 298.2. That's $1.80. Why don't we put that in there? So this is $1.80, and let's format that as currency. And so our actual quantity times actual price, quantity times price, compared to actual quantity times standard price. So if actual exceeds standard, what we expected it to be or what it should have been, then our variance is the difference between the two. And let's take standard minus actual. And so that shows $29,820 unfavorable variance, price variance for direct material. And of course, the first thing we need to do is check it. Yeah, make sure that we're on the right track here. 29,820, and that is unfavorable. And we go to our check my work, keep our fingers crossed, and looks like we're okay. So looks like we're on the right track. So you might be able to tell by what we just did that this isn't really that difficult, but it is time consuming. Okay. So next up is our direct material quantity variance. Again, if we go to exhibit 9.6 in the text and take a look at the formula, direct material quantity variance, and our calculations are actual quantity times standard price, which we have already done here. So we can basically copy this actual quantity times standard price, and that is compared to standard quantity times standard price. I think we need to show this here as actual, because that's going to be compared to standard quantity times standard price. Yeah. So the calculations on the left show us actual. Maybe we ought to make that a little bit more, a little clearer. So we have Actual versus standard or budget. Yeah, okay. Okay. And so actual quantity times standard price, that's 298,200 pounds of clay used times standard price is $1.70 per pound, and we are comparing that to standard quantity times standard price. So our standard quantity would be based on our units produced of 165,000, and our standard quantity per unit is 1.6 pounds. Actual price, standard price is 1.7. Standard quantity would be based on number of pounds of clay used divided by standard quantity per unit, 1.6. Let's try that. Number of pounds of clay used, 298.2. I know I'm getting confused here because I got these on the wrong line. This should be moved down here. Okay, actual quantity used, 298.2 times actual price, which is calculated, and standard price, which is given. And the difference between these two totals gives us our price variance. So for our quantity variance, we're using actual quantity pounds of clay used, actual versus standard. Let's try that. Okay, so our actual pounds of clay used is 298.2, whereas our standard quantity based on units produced. Let's try that here. Okay, so we got calculation. Units produced and sold 165,000 times our standard pounds per unit is 1.6 times 1.6 pounds per unit. Let's try that. Okay, so that's this number here, 165 times 1.6. 264,000. Okay, let's format that as a number. So our actual quantity 2982 versus our standard quantity, that formatting is different, and that could be a little confusing if we have different formatting. Okay, so this formatting should be number formatting as well. Why did the comma show in one but not the other? Right here. Use the comma. Okay, there we go. So our should move this down so that we can show what this is. This is our standard price per unit. And that's a pound. And so our actual quantity times standard price compared to standard quantity times standard price. I'm a little confused here. I believe we did plus minus. I believe this is favorable because our actual quantity was more than our standard quantity. I believe this is a favorable variance. Let's see if that works for us. 58,140. Favorable. Not 100% sure here, but let's see if that's going to work for us. Okay, so we're half right there. It is 58,140. However, it is an unfavorable variance. Let's take a look at that and see how that's working. And I suppose we should be able to tell that it is unfavorable. We're comparing actual quantity, number of pounds of clay used, 298.2, versus, oh, okay, I'm sorry. It is unfavorable, and I'll tell you why. It is unfavorable. For production of 165,000 units, we use 298,200 pounds of clay, whereas based on our standard, we should have used 264,000 pounds of clay. That's this calculation. Actual production times standard pounds per unit. We should have used 264,000 pounds of clay, so we used too much, basically. So when we multiply out by the standard price on both sides, we see that our cost based on quantity was too high. So that's an unfavorable variance. So the number is correct. We just need to change that to unfavorable. Okay. And then when we put these two together, if we go back to Exhibit 9.6, the combination of our price variance and our quantity variance gives us our spending variance. So in this case, they are both unfavorable. So we would add them together, 29,820 plus 58,140. Let's do that on our spreadsheet. And this is going to be our direct material unfavorable. And let's see if that works for us. 87,960. And that's unfavorable. Let's check it. And we are okay. So it takes a little bit of thought, but I think it's helpful having to think this through, because we need to be able to see what we're actually trying to calculate here. So actually this would be better to show here on that line, and insert a row here. And so we could call this price variance, and we could call this quantity variance. Yeah, actually it would probably be even better to simply show it as direct material price variance and direct material quantity variance, and then combination of the two gives us our spending variance. There we go. Okay. So let's see if we can use that basic approach, and that's basically what it is for the labor variances, which are on page 385, exhibit 9.7. If we just use this as a starting point for our labor, so this would be rate, actual rate, and standard rate. Since for labor we're going to be using looking at labor rate, and this is going to be our labor rate and labor efficiency variances. So this will be our direct labor rate variance and our direct labor rate variance. So for our rate variance, again referring to exhibit 9.7 in the text, actual hours times actual rate compared to actual hours times standard rate. So our quantity changes to hours. Okay. Hours. So actual hours used actual hours, number of labor hours worked, 210,000. Okay. And our rate, that's our labor rate, actual versus standard. Our standard rate, first of all, is $14 an hour. $14 an hour. So now we need to calculate our actual rate. Let's see, our information here shows that our direct labor cost was $3,780,000, and the number of labor hours worked was 210,000. So we need to divide those two numbers, direct labor cost by number labor hours worked. So our direct labor cost was $3,780,000. And our hours worked is 210,000. And so that calculation, 3780 divided by 210. That's $18. So as you can see, our labor rate was much higher than standard. So if you can kind of think this through, we're probably going to end up with an unfavorable variance here, based on $4 an hour. 14 versus 18. So this is 18. And so our actual hours times actual rate, 3,780,000, which is what was given up in the problem, versus our standard actual hours versus a standard rate, $14, which should have been 2,940,000. So the difference is $840,000, and that's unfavorable. So let's see if that's going to work for us. Unfavorable. Okay. Let's check that out. And we're okay. Okay. Now for our labor efficiency. That's kind of like direct material quantity. Yeah, except for labor we call it, we refer to that calculation as an efficiency calculation. So we compare actual hours times standard rate. So we already have that here. Control C. Control B. Okay. And this is direct labor efficiency variance. Labor efficiency variance. So this is going to be hours of labor used, actual hours used. Well, let's say hours of labor used. Yeah, hours of labor. I guess we could just say labor hours used. Yeah. Labor hours used, actual and standard. So our actual is 210. Actual hours. And our standard would have been based on standard hours times standard rate. So our standard hours times standard rate. So we know our standard rate is 14. Okay. So what we need to do is figure out what our standard hours would have been based on quantity produced. Units produced 165,000. Standard hours per unit, 1.6. So 165,000. Same calculation, but it's not pounds, it's hours. That might make it a little bit harder to see, but it's the same calculation as we did for materials, except that for materials we were using 1.6. Oh, wait a minute, I'm on the wrong line there. I'm on the wrong line. See, even I got confused there. This is the materials calculation, which was pounds. Oh, we're down here in the labor calculation, which is 1.6 hours per unit. So 165,000 units produced, and our standard number of hours per unit is 1.6, so 165 times 1.6, our standard number of hours would have been 264. Just as, you know, it's the same number up above for pounds of direct labor, but it just so happens to be the same because the number of pounds of clay is 1.6 and the number of direct labor hours per unit is also 1.6. Okay. So our efficiency, direct labor efficiency variance is actual hours was less than standard hours. So it appears that our direct labor efficiency variance is favorable. Now, I'm showing that these amounts are negative because I'm starting out with standard and subtracting actual. So plus C minus B, plus C minus B, plus C minus B. And this is the same here, plus C minus B. So our standard or budgeted direct labor efficiency or usage, if you will, should have been $3,696,000, and our actual was $2,940,000. So it looks like our direct labor efficiency variance is favorable. And of course, if we combine the rate variance and the efficiency variance, it looks like the spending variance is also unfavorable. Let's put in both of those amounts and see how we end up for labor. So our 756, and this one shows as favorable, and then the combination of the 840 unfavorable, 756 favorable gives us an $84,000 combined spending variance, which is unfavorable. Okay, let's check it. Let's hope we're okay here. And we are. We're okay. Okay. All right. Yeah, this takes a little bit of thought. And hopefully, as you think it through, spend a little bit of time thinking it through, I think it'll make sense. Okay. So the last item, the last set of variances that we want to calculate our overhead, just as we calculated variances for materials and labor. We also do the same for overhead. Basically, we're comparing how our material price differs, budget versus actual, how the amount of material we use in production differs, budget versus actual, how our labor rate that we paid differs, budget versus actual, and then how efficient we were at making our product, using our labor to make our product in terms of number of hours, budget versus actual. So this is very useful information. If we do these calculations consistently over time, we can see whether our manufacturing processes are improving or not. Okay, anyway, let's get to the last set of calculations, which is our overhead rate, overhead efficiency, and overhead spending. And for that, we go on to the next exhibit in the text on page 388, exhibit 9.8, calculating variable overhead rate and efficiency variances. So our just as we did, let me color these. That might make it a little easier to tell apart. Okay, so our materials are shown in yellow, and our labor, we'll show this in green. Okay, so we'll show the overhead in gray. How's that? Make a copy of labor, move it down, and change the color to gray. How's that? Okay. So we are working in overhead rate. Overhead rate variance. And overhead efficiency variance. And overhead spending variance. Okay, now the formulas for overhead rate. Actual hours times actual rate. Now we're talking about overhead rate, not our labor rate. So our actual hours times actual rate. Let's see. Our standard overhead rate is $1.6 based on okay, so it's 1.6 based on direct labor hours. That's a quantity, number of hours for variable overhead at $1.30 per hour is our standard. So our standard rate is $1.30. Actual hours used, I believe, based on, hold on one second. Okay, sorry for that interruption. Let's get back to the last section of this problem Pa9-1, calculating the variable overhead rate efficiency and spending variances. So this is the overhead works more like the labor, and we got this thing, the setup started here, and we are referring to the text on page 388, exhibit 9.8 for variable overhead rate and efficiency variances, as well as the spending variance. So for the overhead rate variance, we take a look at actual hours times actual rate, and the actual hours used, let's see, based, I guess I can get that off of the spreadsheet. The actual hours used is overhead is based on direct labor hours. So number of direct labor hours worked, 210,000. So our overhead hours will be 210,000. Actual hours used, and the overhead rate is different from the labor rate. So our standard overhead rate is $1.30 per hour. So that's $1.30 for the standard or budget calculation, and we need to get the actual overhead rate, and to get that we calculate based on variable overhead cost, 320,000 divided by number of labor. Actually, what I should do here to make this a little clearer is you say labor slash overhead hours worked. So we divide it by the total labor hours or overhead hours of 210,000. So that's 320 divided by 210. So that's 320 take out 1 0. 320,000 divided by 210,000. $320,000 divided by 210,000 hours. So that's oh boy, that's it's not an even amount. That's 1.5238. So we'll use 1.52. And so using actual hours times the actual rate compared to actual hours times the standard rate, our actual exceeds standard or budget by 46,998. So that's unfavorable. So let's put that in here and see if we're on the right track here. 46,998. And it's unfavorable. And let's check that out, and hopefully we are okay there. 46,998. Okay, I'm thinking we got something wrong. Do not round your intermediate calculations. Do not round your intermediate calculations. So let's see if variable overhead cost I wonder if we need to include our 320 divided by 210. Let me make this a formula. 320 divided by 210. Okay, that actually changed the amount by $2. That's probably a rounding difference here. 47,000 unfavorable, and let's check that out. And now we're okay. Okay, we're off by $2. That was a rounding difference. Okay, now for variable overhead efficiency, let's go back to our spreadsheet. And we're referring to Exhibit 9.8. One calculation is our actual hours times standard rate, which we have here. We need to change the rate. And the second calculation is standard hours times standard rate. So our standard hours would be based on production and overhead rate. So production was 165 and the overhead rate was 160. So I believe our calculation here would be the same. 165,000 units at 1.6 hours per unit, and that's the overhead hours. So standard hours, okay. And this should be hours, and I believe I forgot to change it up here as well. Hours, okay. So 165 divided by 1.6. That's not right. Standard price per unit. Standard rate. This is standard rate. And I need to change that terminology under the labor. Standard rate. Okay, so standard hours, I'm sorry, we're looking for standard hours times standard rate. So getting confused there. Standard rate is $1.30. and that's the same number on both calculations. So our actual overhead usage comes in at 273. Our budgeted comes in at 343, so we are better than budget by 70,200. So let's try that. 70,200, and that's favorable. And let's check that out. We're okay there. And then to get the spending, we combine the two. We have our formula set up here. So our spending for overhead usage, our variance is 70,000 favorable. For overhead rate, our variance is 47,000 unfavorable. So we have a net favorable variance of 23.2. Let's try that in there, 23.2, and that's favorable. And we'll check that. And looks like we're okay. Alright, so not quite as simple as it may seem, although you really have to follow these formulas in the text. Exhibits 9.6, 9.7, and 9.8, they basically show you how to calculate these variances. Coming up with some of the information here is a little tricky. These calculations, you need to kind of think through. The calculations for the labor and overhead are very similar. The material is, I guess they're all pretty similar. But you use the actual results to figure out the calculations. The overhead information, by the way, is just for variable overhead, not for fixed. And that's basically what it's asking for: variable overhead, rate efficiency, and spending variances. Okay, so let's see if let's run that check my work one more time. And it looks like our answers are complete and correct. So if we select submit and submit, and we do have 15 out of 15, return to assignment list, and looks like I got timed out, but I should be okay. Could probably sign in again right here. Yeah, and go back to the assignments, and that problem is correct. 15 out of 15. Okay, there we go. So I'm going to close it here and process this video, send it out, I'll put it on YouTube, send out the link to everyone. And for those of you that might need more time, maybe another day or what have you, to get these assignments done for Chapter 9, let me know, and I'll extend your due date. Otherwise, keep shooting me your questions, or let me know if you need assistance with any of this material. Thanks a lot. Have a great Sunday evening, and I will talk to you again soon. Aloha.